Hello, you're on Pablo Spot. I'm George. If you have been working on modern day applications, your backend applications are most likely running in some form of containers. And in one of my old videos on this channel, I showed you a Terraform provider that allows for the process of building and publishing of Docker images to be integrated into your infrastructure code. One of the challenges that I face with using this provider though involves having to rerun Docker build every time I run Terraform commands, regardless of whether I change my Docker container code or not. So let's switch to my VS Code to investigate on this further. Without going through my application in too much detail, I have here a simple Express application that simply writes "Hello World" when the endpoint is accessed. If I head to my terminal and start installing all the dependencies for my Express application, and then run this Express application, let me open a new terminal so we can test. And if I go ahead and run a curl command against my localhost endpoint on port 3000, I get the hello world. Now let me go back to the other terminal and then stop my Express application and go back to my code. If I want this to be deployed as a Docker container, I would start writing a Docker configuration file for my Express application. So let's do that. So inside my app directory, I'm going to create my Docker file. Let's switch to my VS Code terminal and build my Docker image. I'm going to start running my Docker container against this Docker image. And if I go ahead and start running the same curl command that I ran earlier, I get the hello world message back. Before I proceed to the next set of changes, let me just quickly do some housekeeping. So let me stop and remove the Docker container that I just started. And then remove my Docker image. What I'm going to do next is set up my Terraform code such that the Docker build process is integrated into the infrastructure code. So let me run my script that generates a set of baseline Terraform code. I need to generate my Terraform code in the root of this repository, so I will move one directory higher and then run my template Terraform script. And now if I switch back to my code explorer, I now have a shell of Terraform code created for me. So let's start updating this code. Let's open up my main.tf. So the first thing I will do is create an AWS ECR repository resource where I am going to push my Docker image to. This resource needs a bare minimum name property, so let's set that up. I also need to create my Docker image resource, but before I do that, I need to tell my code to reference the necessary provider for Docker. So let me open my backend.tf and define the required providers block for Docker. If you want to get more information about this provider, I will provide the necessary links in the description below for your reference. Now that my required provider reference is set, let's go ahead and configure the actual Docker provider block inside my providers.tf, which will allow me to start reference resource blocks specific to Docker. So let's open my providers.tf and create the providers block for Docker. Because I intend to push my Docker images to AWS ECR, this provider block requires the necessary authorization to AWS ECR. This registry authorization block will require an address, username and password properties that I will need to provide. What I will do next is set up all my data references that will instantiate all the necessary ECR authorization values and tokens to make the registry authorization work. So let me open my data.tf. I need access to the relevant AWS account ID, which is available in the AWS caller identity data reference. I also need the ECR username and password, which are available in the AWS ECR authorization token data reference. What I need to do next is plug in the relevant values back into the registry authorization on my Docker provider block. So let's go back to my providers.tf. To set up the registry address, I need to extract the AWS account ID from the caller identity reference like so. And then plug in the standard AWS ECR string. As for the username and password, I can extract the relevant values from the ECR authorization token. Now that all those preps are done, let me switch back to my main.tf and start creating my Docker image resource. This resource needs a name property which I will set using the repository URL of my AWS ECR repository resource. This resource also requires the build block, which needs to have a value for the context. This property needs to point to the appropriate Docker context, which in my case will be my app directory. I also need to add another resource called Docker registry image, which will take care of pushing the Docker image into AWS ECR. This resource needs a name property, and I will set the value to point to the name property of my Docker image resource. So this is the simplest way to set up Docker image into Terraform code. Now we are ready to build my Docker image and push it to ECR. So let's switch to my VS Code terminal, initialize my AWS credentials, and then run the necessary Terraform commands to stand up my resources. Before I run Terraform apply, let's quickly review the output of the plan. So let's expand this output. So this will create an AWS ECR repository, a Docker image, and the Docker registry image, which will take care of pushing my Docker image to ECR. So now let's go ahead and apply this change. So that looks good. What I want to point out is that when I ran Terraform apply, I ran it on my machine. So this means if I list down the Docker images on my machine, it should give me just that one image that I built when I ran Terraform apply. So let's go and check that out. Here's one thing to take note. If I turn off Docker on my machine, so let me go ahead and turn that off. So I've turned off my Docker application. If I rerun Terraform plan, watch what will happen. The plan fails. So let's expand this output. What this output tells us is that the Docker image resource relies on the Docker instance running on a machine where you intend to run your Terraform commands in. This is particularly important when you start integrating this process with CI/CD tool. And what you need to remember is that Docker needs to be installed in the build agent where you intend to run Terraform from. Now that we know that part, let me turn my Docker back on. And now if I rerun Terraform plan again, it tells me nothing has changed. Now imagine this. Let's say someone else pulls my code into their machine and attempts to run my code. And the only way to mimic this is to simply delete the Docker image on my machine. So let's go ahead and do that. And now I'm going to rerun Terraform plan. The summary of the output says one resource will be added. So let's expand this output. The Terraform plan result shows that a new Docker image will be built. I have not made any code changes, so rebuilding my Docker image will be unnecessary. Let me show you something. In the Terraform provided documentation for Docker image, it says here I can add triggers to stop rebuilding my Docker image if no code changes are made. So let's switch back to my code and implement this. What I need to do is add a new property block inside my Docker image resource. So let's head to that code. And based on the documentation, it says I need to add a new property called triggers. I can set any arbitrary value in here to indicate changes to my code. So let's say I'm setting a property called dir_hash. And I will set the value of this property based on the hash value of a string. And this will be made up of a concatenated value of all hash values of each source file. So the first thing I will do is loop through each file inside my app directory and call the file set function. And then I will call file SHA-256 function to get the hash value of each file. And then I will concatenate or join all of these strings together. And then call the SHA-256 function to get the hash value of the final string. My Express application is written in Node.js, and when I compile this locally, a directory called node modules is created, which I really don't need in my file list. So to exclude them, I will update the code to exclude files that contain /node modules/ in them. So it should look like this. If I go ahead and run through this change, so let's switch to my terminal and run Terraform plan, the result still tells me that my Docker image will be rebuilt. So the trigger setting did not work. This is because the Terraform command will always try to sync up against the Docker images that are on the machine where I am running Terraform against. So if the Docker image is not there, Terraform will always try to rebuild the Docker image. And this is where you start putting your creative hat on and figure out a way to implement this. Because I tell you, rebuilding a Docker image without code changes is an overhead and unnecessary, especially when you start working with large Docker images. So let's look at some options. One option I did in the past involves tagging my Docker images using the associated commit hash. This way, I can easily associate my Docker image against the changes I have made in a particular Git commit. This also gives me certainty that the Docker image I push to my ECR will always be unique. So let's go ahead and implement this. Let me go back to my code and let's comment this trigger block for now. I need to run an external command to fetch the associated commit SHA on my Git repository. So this is essentially like running a Git command on your terminal. So let me go to my data.tf and I will define a new data reference for an external command. And inside this block, I will define a program property that will run a shell command for an external script. Let's leave this code in here for now and go to my Explorer and create a new directory called scripts in the root of my repository. And inside this directory, I will create a new script and call it git get_sha. And this shell script will do nothing but run the relevant git command and return a JSON format output. And now, let me head back to my data.tf and set a reference to the new shell script that I just created. And now back to my main.tf. In my Docker image block, I will then update the name property to use the git hash value extracted from my external program. In fact, what we can do is head to my locals.tf and define a new local parameter called sha and set the value using the output of the data reference to the external program. And now I can go back to my main.tf and replace this to use the new local parameter. Now, this next set of changes are what I need to make sure that the image does not get rebuilt if it already exists. What I need is a data reference that pulls all image tags for the image that I push to ECR. So let's go back to my data.tf and define a data reference for AWS ECR image. I am going to set the repository name property to point to the AWS ECR repository name. And then I'm going to add a most recent property to pull the latest image. And then I will also make sure that this data reference depends on my AWS ECR repository resource. And now back to my main.tf. In my Docker image resource block, I will define a count property. This will be my condition to create or not create the Docker image resource. And the condition will depend on whether the tag I want already exists in my ECR repository or not. To achieve this, I will fetch the image tags property from my AWS ECR image data reference. And then check if this list contains my git_sha. In fact, what we can also do is copy this logic in here and then go to my locals.tf and then define a local parameter for whether creating a Docker image will be required or not. So I'll define a local parameter and call it create image. And because this contains function will always return true if my git_sha is in my image tags, I will reverse the logic by adding a bang in front of the contains function. So what this means is that if my local sha does not exist in my image tags, my create image will be set to true. Now, if I go back to my main.tf, my count condition will then become my Docker image resource is being referenced by my Docker registry resource. So what I need to do is also update my Docker registry with the same condition. So let's copy that and then head to the end of my main.tf and put that condition in there. I also need to break the dependency between my Docker image and Docker registry image. So instead of relying on my Docker image name, I'm going to copy the same name property from my Docker image and set that as the value for my Docker registry. When my Docker registry image resource is being cleaned up or destroyed, I want my remote images to remain in AWS ECR. So I will add a new property called keep remote and set the value to true. And lastly, I want my Docker registry resource to depend on my Docker image resource. Now, let's switch to my VS Code terminal. Before I start running Terraform commands, remember that my Docker image build is now dependent on my Git commit. So let me commit my local changes. Also, note that I started using a new provider called external for my external program, of course. But the associated built-in provider for this is not loaded on my machine yet, so I need to rerun Terraform init. And now I'm going to run Terraform plan. Because this is my first time to run this set of code changes, I will go ahead and apply this. And now I am going to do the same thing as what I did earlier. So let's delete my local Docker image. And then rerun Terraform plan. The summary says one resource will be destroyed, so let's open that output. And notice that the Docker image resource is not in the output, which means my Docker image is not going to be rebuilt. But because the Docker registry resource earlier is dependent on the Docker image resource, which has not changed, Terraform will clean up the Docker registry from the state, which is perfectly fine. So let's go ahead and apply this change. And now we have a solution that solves the problem of not having to rerun Docker build if there are no changes to my code. But this has a problem, and I'll show you what it is. If I switch back to my code, there are two parts to this problem with this setup. First one is, if I make a code change on my application, so let's expand the app directory and open my app.js file. And suppose, let's do a code change. Instead of hello world, let's say hello universe. And then head to my terminal and start updating my infrastructure. So let me run Terraform plan. The Terraform plan says no change, and it is not going to recreate the Docker image, but I have made a code change. The reason why the build is not triggered is because I have not committed my change yet. And this is probably a good thing to ensure you commit your changes regularly. But if you're like me, who every once in a while forgets to commit changes, this could come a little annoying when you just want to push your Docker image and deploy it to, say, a different environment apart from your local machine. There is another problem to this implementation that I would like to show you. So back to my code, and let me revert my application change. So put the hello world back. So now I don't have any changes to the application. But when we deal with large set of infrastructure code, sometimes we put a lot of related resources together. What this means is in my main.tf, I could have another set of resources here that I could use in line with my Docker images. Like for example, ECS services or cluster resources or even security groups. So let's pretend, for example, that I need to add a new security group resource in my code. Just to point out the obvious, I have not made any application changes, but I made infrastructure code changes. Now let me go to my terminal. And this time, I am going to commit my change. And if I go ahead and run Terraform plan, now let's expand this output. This result shows that the Docker image will be rebuilt. But I have not made any changes to the source code. This is because we obviously rely on the git commit hash to trigger the Docker image build. So my fix for this is to tag my Docker images based off the hash of all my source files. So let's go back to my code. So let me change the way I tag my images using the hash value of the source files. So I will move this dir hash code right here and head to my locals.tf and plug that in. So what I need is to define a local parameter called dir hash. So let's flesh that out. And then go to my main.tf and use the dir hash local parameter as a tag for both my Docker image and Docker registry resource. And because I'm not using the SHA local parameter anymore, I can then go ahead and clean up all the related code. So let's go to my locals.tf. And then on my data.tf, I can get rid of my external data reference. I'll keep my scripts in there just in case I need it for future reference. The other change I need to do is on the create image local parameters. So let's head to my locals.tf. And then what I need to check this time is instead of local SHA, I will use the dir hash. And for clarity, I'm just going to move the create image below the dir hash parameter. This change addresses the two problems that I showed you earlier. If I make a change to my application and I'm not going to commit my changes just yet, or if I make code changes to other infrastructure resources. So let's go back to my code. Now let's switch to my terminal and let's run Terraform plan and apply this change. Now let's go ahead and delete the Docker image and run Terraform plan again. And as expected, this is going to destroy the registry image. So let's go ahead and apply this. And now if I run Terraform plan again, there are no changes to be implemented. Now let's go back to my code and make some changes to the application. So let's reinstate our change and say hello universe. Go to my VS Code terminal and then run Terraform plan. The summary says 2 resources will be added, so let's expand the output. And I can see straight away from the output that my Docker image will be created, which is what we expect because we changed the application code. So let's go ahead and apply this change. And now let's go back to my code, head to my main.tf, and then all the way to the end of this file, let's add another security group. So this time, I'm not making any application changes, but I'm making infrastructure changes. So let's go back to my VS Code terminal and run Terraform plan. Let's have a look at the output of this plan. And there you go. The Docker image is not going to be built. There is a saying that goes, there are more than one way to skin a cat or a chicken. I saw other implementations addressing this Docker rebuild problem by pulling the Docker images from ECR into their local machine or on the build agent. But in my opinion, this is an added overhead. I would prefer pulling a smaller metadata than letting a large MB of data to flow through the network, which can be very slow. Anyways, that's all I have for today. Let me know what you think in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.